Hi class, this is lesson 7.5, apply the tangent ratio. So this lesson starts a couple units that we're going to do that are on trigonometry. And one thing I want you to remember, so I'm going to put a star right here, is this is only for right triangles. The tangent ratio works when we are using right triangles here. So if we let triangle ABC be a right triangle with an acute angle A, the tangent of A, written as, we write like this, tangent A, is defined as the following. So over here on the left, we got remember, it says remember these abbreviations. So tangent is going to be TAN, opposite is OPP, and adjacent is ADJ. And sometimes I will also just put an O for opposite and an A for adjacent on my opposite and adjacent sides. So right here it says tangent of A equals the length of the leg opposite of angle A over the length of the leg adjacent to angle A. So let's look at our triangle right here. Here's angle A right here, and what you'll see as we move into Algebra 2 next year, put a little angle mark and they'll actually call this our theta. So the angle that we're looking at is our theta. Now the leg opposite our angle is going to be the leg straight across from it. The leg adjacent to it is the leg right next to it. And our hypotenuse is still called our hypotenuse. So opposite is across from our angle, adjacent is next to our angle. So I labeled this my adjacent side and this is my opposite side. So the length of the leg opposite angle A would be CB. Remember that stands for the distance from point C to B. And the length of the leg adjacent to AB, my adjacent leg length, would be AB. Just two capitals, no line over them, means the distance. So sometimes you'll see me write it like this. The tangent of A equals opposite over adjacent. And opposite, that means the opposite leg and the adjacent leg. Sometimes I'm also going to write TOA. We'll add to that, but TOA means tangent is opposite over adjacent. So when you hear me say TOA, that's what I mean, T-O-A. All right, let's do our examples here. So it says find the tangent ratios. Find the tangent of S and the tangent of R, and then write each answer as a fraction and as a decimal rounded to 4 places if necessary. So it says as a fraction and as a decimal rounded to 4 places. So we need to do both of those two things. So the tangent of angle S, well, let's find where our theta is. S is right here. There's my angle. So here's my angle S, the theta I'm looking at here. Again, theta just means what angle I'm looking at. And it's opposite over adjacent. So the angle opposite S, or the side opposite S, is 60, and the leg adjacent to S is 25. So my opposite would be 60 over my adjacent is 25. So my tangent of S is 60 over 25. And that's written as a fraction, but it's not in reduced form. So if you divide them both by 5, you get 12 over 5, and that is my fraction. And if you put that into your calculator, you will get 2.4 exactly. There are no more decimals, so there's my decimal form. So there's my fraction form and my decimal form. The tangent of R, so my angle I'm looking at is right here. That's my angle or my theta. So here's my angle, and I need the opposite leg. So my opposite leg is right here, and that's length 25. Over adjacent, my adjacent leg is right here. That's 60. I didn't use 65 in either one of these because that's my hypotenuse, and I'm not using the hypotenuse for tangent. So again, for the tangent of R, it's opposite over adjacent. So that's 25 over 60. And if you reduce that, you get 5 over 12. So there's the fraction form. And if you put that into your calculator, and it says round to 4 decimal places, you will find that that's approximately 0.4167. And that would be to 4 decimal places. This next one on your own, I highly suggest you pause it and try it on your own. It says find the tangent of B, so we're going to do the tangent of angle B, and we're also going to do the tangent of C. Write each answer as a fraction and as a decimal rounded to 4 places if necessary. So tangent every single time is opposite over adjacent. So for both of these, we're going to do the opposite over the adjacent. And the opposite and adjacent depend on what angle you're looking at. So for this first one, we're looking at angle B. Angle B is right here. 50 is my hypotenuse. It's across from my right angle. I'm not using it. My opposite leg would be 48. My adjacent leg is 14. So it's 48 over 14 for the tangent of B. So 48 over 14. And if you reduce that, divide them both by 2, you get 24 over 7. So this is your reduced fraction. And if you put that in your calculator, you'll find that it's about 3.4286. That's rounded to 4 decimal places. For the tangent of angle C, well, C is my theta, my angle I'm looking at. So here's my angle right here. I want the opposite, which is 14, over the adjacent, which is 48. Again, we're not using this one, the 50, because that's the hypotenuse. So opposite over adjacent. That's 14 over 48. And if you reduce 14 over 48, you get 7 over 24 for the tangent of C. Putting that into your calculator and reducing it and rounding it to, not reducing, but rounding to 4 decimal places, you get 0.2917. All right, let's look at the next page of our notes. Okay, so this says find a leg length. So we're going to find the value of x here. Now I know my angle is 31 degrees, and I need to find x, and I know one of my sides here. So what I'm going to do is I'm going to say, okay, here's my angle, that's my theta. This x is the leg right next to it, so that's my adjacent leg. And the 17 is a leg across from it, so that's my opposite leg. And I know that tangent of an angle, so tangent of an angle, I'm just going to put theta for an angle, equals opposite over adjacent. So I can write tangent of my angle that I have here is 31 degrees equals opposite is 17 over adjacent is x. Now to solve this problem, what I'm going to do is I'm going to turn this left side into a fraction, and then I'm just going to cross multiply. So 1 times 17 is 17 equals x times the tangent of 31 degrees. Now I want to get that x alone, so I need to move the tangent of 31 to the other side, and I'll do that by dividing both sides by the tangent of 31 degrees. So those cancel out right there. So I have x equals 17 divided by the tangent of 31 degrees. And if you put that into your calculator and round, it doesn't say what to round to, so I'm just going to round to 2 decimal places. You'll find that that's approximately 28.29. So you just put into your calculator 17 divided by tangent of 31 and make sure you get 28.29. If you don't get that value and you put it in correctly, your calculator might be in the wrong mode. Ask me about it in class. So let's look at the next one. It says find the value of x. So my angle is the 63 degrees, which is right here. So there's my theta. X is right next to it. This is my adjacent side. And 13 is across from it, that's my opposite side. So I know that tangent of an angle equals opposite over adjacent. So the tangent of my angle is 63 degrees equals my opposite side, which is 13, over my adjacent side, which is x. So I set up my problem. Now I'm going to turn both sides into a fraction so I can cross multiply. So my left side, I just need to put it over 1. So cross multiplying, 1 times 13 is 13, equals, cross multiply here, you have x times the tangent of 63 degrees. Now I want this x alone, so to get that alone I need to move my tangent. Since they're multiplied, I'll divide both sides by the tangent of 63 degrees. That allows that tangent of 63 to go away, and it leaves me with an x on the left, equals 13 divided by the tangent of 63 degrees. And if you put that in your calculator and simplify it, again, it doesn't say what to round to, so I'm just going to give me 2 decimal places. You'll get 6 and 62 hundredths, so 6.62. Let's look at this next problem here. Again, let's identify our pieces. It says find the height h of the lighthouse to the nearest foot. So my angle that I'm looking at is right here. That's my 62-degree angle. The 100 feet right next to it, that's your adjacent side. And h is right across from it, so that's my opposite side. So I know, once again, that tangent of an angle, which my angle here is 62 degrees, equals opposite. My opposite is h over adjacent, which is 100. So to solve this problem, I'll make my left side a fraction again, and then cross multiply. So tangent, I'm going to put over 1, and I'll cross multiply. 1 times h is h, equals tangent of 62 times 100. We'll write that 100 times the tangent of 62 degrees. Now if you notice here, this right side is all just numbers I can put into my calculator. My h is already alone. I don't need to do anything to solve for h. You just put into your calculator 100 times the tangent of 62. And if you do that, you'll find that h is about equal to, I'm saying about equal to because we're going to have to round it, 188.07. Now looking back at the question, it says to the nearest foot. So that would give me actually 188, and my units there would be feet. Because it's a real life situation, I need to include my units. All right, let's look at the last example here. It says find the value of x. Part A says use the definition of tangent. Part B says use 45, 45, 90, or 30, 60, 90 triangle theorems. So using the definition of tangent, here's my angle right here. It's 60 degrees. Right next to my 60 is my x, so this is my adjacent side. Across from my 60-degree angle is 15. That's my opposite side. So I can say the tangent of 60 degrees equals opposite, which is 15, over adjacent, which is x. I can turn the left side into a fraction now so that I can solve it. So I'll put it over 1, then cross multiply. 1 times 15 is 15, equals x times the tangent of 60 degrees. I want to get x alone. They're multiplied, so I'm going to divide both sides by the tangent of 60 degrees. And that leaves me with x alone on the right. So x equals 15 divided by the tangent of 60 degrees. And if you put that into your calculator and then round it to 2 decimal points, you'll find that it's about 8.66. Now I'm going to actually write this whole decimal out because we want to, if you look down in part C, it says compare your results. I want to be able to compare my results here. So if I write this entire decimal that my calculator gives me, it's 8.66, 8.66025438. And just copied that whole thing from my calculator so that I can compare my results a little bit better. All right, using the 45, 45, 90 or 30, 60, 90 triangle theorems next. Now looking at this, I know I have a 60-degree angle right here. So this side must be 30, or that angle must be 30. So I'm going to use my 30, 60, 90 triangle theorems. And if you look back at your notes for 30, 60, 90 triangles, we've got a couple theorems, and I need to know which is my leg, or my shortest leg, my longest leg, and my hypotenuse. So looking here, I've got this angle, that's 60. This is my longest leg, this is my shortest leg, and this is my hypotenuse. So this bottom side would be my S, the 15 would be my L. Now, I know, relating my shortest and my longest side, I can say my longest leg equals my shortest leg times the square root of 3. And then I'm just going to plug my values in that are on the picture up above. My longest leg is 15. My shortest leg is x times the square root of 3. If I divide both sides by the square root of 3 to get my x alone, I find that x equals 15 divided by the square root of 3. Now I want this in decimal form so I can compare them. So I'm not going to get my radical out of the bottom there. I'm just going to put 15 divided by the square root of 3 in my calculator. And if you do that, you'll find you get about 8.66, which looks like it's the same as the one up above. But let's write out the entire number from our calculator. If you write out your entire number, you get 8.660254,038. The last one is comparing them, and look at, you get exactly the same amount, the same results, whether you use the definition of tangent or you use your 30, 60, 90 triangle theorems. So to compare your result, I'm just going to put a note here. They are the same. Either method works, and both methods are accurate. So this is the end of the lesson. Please make sure if you have any questions, you ask me about it tomorrow in class. Have a great day.